Hi, my name is Yasin Koç, staff researcher at InterDigital. Today we are demonstrating energy-efficient edge intelligence, a live multi-user MIMO over-the-air federated learning demo in collaboration with Keysight and UTOS. As we move towards 6G, integrated AI and communication is a central design principle. Federated learning lets devices train models collaboratively without sharing raw data. But in digital federated learning, each device needs a dedicated channel, so the latency scales with the number of devices. On the other hand, over-the-air federated learning enables simultaneous transmission on the same resources. So the signals combine naturally over the air. And that's why we don't need to, the latency doesn't scale with the number of devices. However, there are significant challenges for the over-the-air federated learning, including wireless channel fading, the path loss, and also the multi-antenna processing. And in this demo, our solution comes with the enabling multi-antenna processing so that the models are going to aggregate it over there in a such a way that we can recover the aggregated model at the base. And in this demo, we first perform some simulations, and our task is for image classification. And we perform the over-the-air federated learning setup with 4 UEs with 2 antennas, and then at the base at the G node we have 16 antennas. And we compare we observe that over-the-air federated learning can achieve higher accuracy, and it has like the low overhead compared to conventional digital federated learning. And also, we look for the energy efficiency aspect, and then we can see that we can improve the energy efficiency around 50% at minimal cost, and then it can perform, it can enable OTA-FL to perform at challenging conditions on the cell edge. Now I can hand it to Irene about the hardware and the live demo setup.
Thanks, Asel. My name is Irene Kwong. I'm an application engineer for Keysight. And so as our wireless systems are moving towards advanced 5G and 6G, traditional stochastic channel models are no longer sufficient to capture real-world channel propagation behavior. So Keysight RaySim is a deterministic physics-based ray tracing approach to create high-fidelity RF digital twin of an environment. So we model real geometry, materials, propagation effects, mobility, and extreme MIMO behavior. So RaySim generates these channel models that then feed into the PROPSIM, which is Keysight's channel emulator. And this accurately reproduces real-world and over-the-air channel conditions for lab-based testing with real devices. So together, the Keysight RaySim and PROPSIM enable realistic, repeatable validation of advanced 5G and 6G technologies before field deployment, which accelerates development cycles. And now I'll pass to Suyash from UT.
Thank you, Irene. So, hi, I'm Suyash Pradhan, a PhD student at UT Austin. Here we have developed an experimental test bed with Keysight tools and guidance from InterDigital. So it involves one USRP X410, where we have 4 UEs. So we create a multi-user MIMO environment with 4 users. The wireless environment is a complex, rich multipath environment with a scene in Finland. So in an outdoor environment with actual path losses and site-specific channels imported in this PROPSIM, we validate the OTA-FL concept. And on the base station side, we have another X410, which has multi-antenna capabilities. So with help of efficient pre-coding and combining strategies, we ensure that this concept works well in practice. Now, if we look at the dashboard, the key results to note are we try to benchmark the conventional federated learning and the OTA-FL solution which we are proposing. So in OTA-FL, we achieve the same performance as compared to digital FL. But what we observe is OTA-FL consumes comparatively fewer number of slots, around 500 slots when validated on the test bed, whereas digital FL takes around 10,000 slots. So this is a huge deal in terms of spectrum savings. And not only spectrum, since it's fewer slots, these fewer slots can be quickly processed at the base station. So this ensures that the base station can operate in a much more energy efficient manner. And this way we enable energy efficient edge intelligence at 6G at UT. Thank you.